In this lesson, I'm going to go over how to combine radicals by adding and subtracting. So you're just going to add this to the notes that you already started. So you will need that paper and pencil just to continue on your notes that you already started. So to add and subtract radicals, all it is really combining like terms. So to combine like radicals, you're just looking for what's underneath the radical to be the same. So let me show you an example. So example 1, so this says simplify the radical and then combine like terms. So if you can simplify, you're first going to need to simplify, and then you can combine like terms. So here I have 2 square root of 3 minus 5 square root of 3. What's underneath is square root of 3, that's already simplified. So these both have a square root of 3. So I have 2 square root of 3 minus 5 square root of 3. So what I could do is I could just do 2 minus 5 is negative 3 square root of 3. And then you're done. So it's really just combining like terms. Notice what's inside the radical didn't change, just what was out front changed. So I just did 2 minus 5, and then I have my square root of 3. So let's look at another example. So notice you're just going to check, are those radicals the same? Yes, they're both square root of 11. Those both can't be reduced. So I'm just going to combine my like terms. So I'm going to do 2 plus 5. So 2 plus 5 is 7, square root of 11. 2 square root of 3x plus 5 square root of 3x. It's okay that there's an x underneath there. All you're checking is, are these radicals the same? And notice what's underneath the radicals are the exact same. So since they're the same, we can just add the numbers that are up front. So 2 plus 5 is 7, square root of 3x. And this is your answer. This is fine. Nothing to reduce there. You just leave it like this. Example 4. So 7 square root of 2a minus 3 square root of 2a. So I want you to give that one a try. Check, are the radicals underneath, what's underneath the radicals the same? If they are, combine like terms. So hopefully you gave this one a try. You realized that what was underneath the radical, they both had a 2a underneath there. So you just combine like terms. So 7 minus 3 is 4, and then they both have the square root of 2a. So here, example 5, 2 square root of 6 minus the square root of 54. Notice, remember, the square root of 6, we saw that in the last video. That's fully simplified. I can't reduce square root of 6. But 54, I'm going to kind of use a little bit of logic here because I know I want my square roots to match. Notice right now they don't match, but if I want them to match, I'm going to see if I can divide 54 by 6. So if I do 54 divided by 6, I get 9. So it's 9 times 6. Is 9 a perfect square? So if you think of your perfect squares, I have square root of 4 is 2, square root of 9 is 3. We could really stop there. There's square root of 9. So yes, that's a perfect square. So I could rewrite this as, let me just erase that. So I could write this as 2 square root of 6 minus the square root of 9 times 6. But we could split this up because that product property says this would be 2 square root of 6 minus the square root of 9 times the square root of 6. Well, we know the square root of 9. The square root of 9 is 3. This is 2 square root of 6 minus 3 square root of 6. Now, are those the same? Are the radicals the same? So here I have square root of 6 and square root of 6. So they're the exact same. So I can combine my like terms. So 2 minus 3 is negative 1 square root of 6. Or if you would like, you could just type negative square root of 6. So either one of these answers would be correct. So if the radicals, if what's underneath the radicals isn't the same, you might have to reduce, and that's fine. You're just going to reduce and then see if they match. So 2 square root of 3 minus square root of 27. Now I want to get, notice square root of 3, that's fully simplified. So I'm going to try to split up 27 using 3. So that would be 3 times 9 is 27. So this would be negative square root of 9 times 3. My product's property says I could split that up as negative square root of 9 times square root of 3. So we know the square root of 9 is 3, so this would be negative 3 square root of 3. And then I'm going to bring down the 2 square root of 3 in front. So now, is what's underneath the radicals the same? So notice here I have square root of 3, and here I have square root of 3. What's underneath is the same, so I can combine my like terms. 2 minus 3 is negative 1, square root of 3, or just like before, you could do negative square root of 3. So either way is correct. And that's pretty much the extent of these. Sometimes you'll have to reduce both radicals, so I'm just going to write a list of my perfect squares. So I know square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, and square root of 81 is 9, and I can stop there because that's greater than 72. So I would just check which of these is the greatest that I could divide by 70, that I could divide into 72. So I'm just going to check, whoops. I'm just going to check these numbers. So 4, 9, 16, 25, 36, 49, or 64. Which of those goes into 72 evenly, and which one is the greatest? So I'm just going to start 64. It would go into 72, but there would be a couple left over, so it would be a remainder. Same thing with 49. Doesn't go in there evenly. 36 doesn't go in there. No, it does. So 36 would go in there twice. So I'm going to use 36. So this would be 36 times 2. So I would write this as square root of 36 times 2. So this is square root of 36, square root of 2. So this is 6 square root of 2. Now I'm going to simplify the square root of 50. So 50, hopefully this one's a little obvious for you. You could divide 50 by 2 and you'd get 25. This would be 25 times 2. So this would be square root of 25 times 2. Let's put a plus sign in between. So this would be square root of 25 times square root of 2. So we know the square root of 25 is 5, and the square root of 2 is just square root of 2. 5 plus 6 is 11. Square root of 2 can't be reduced. So this would be 11 square root of 2. So you may need to reduce both radicals, and if you have that as the case, that's fine. You're just going to go ahead and do that process, reduce both radicals, whoops, and then see if you can combine them. So I have one more, example 8. So 3 square root of 12 minus the square root of 48. So let's reduce 12 first. So square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and I can stop there. So 12 is divisible by 4. So this would be 4 times 3. So this would be 3 square root of 4 times 3. So 3 times the square root of 4 times the square root of 3. Square root of 4 is 2, so this would be 3 times 2 square root of 3. So this is 6 square root of 3. Now the square root of 48, I'm going to see, can I divide 48 by 3? Because if I want these two to be the same, I would need to have a 3 underneath this radical. So let's see if I could do 48 divided by 3. I would get 16. So I could write this as negative square root of 16 times 3. Product property, apply that product property, so square root of 16, square root of 3. Square root of 16 is 4, and then we have square root of 3. So we'll just write this down here. So square root of, so I have 6 square root of 3 minus 4 square root of 3. Is what's underneath the radical the same now? The answer there is yes. I have square root of 3 underneath both radicals, so I'm just going to combine like terms. So 6 minus 4 is 2 square root of 3. So just keep in mind, you always want to make sure that you reduce the radical. When you reduce the radical, you may be able to combine at the end. Sometimes you won't, and that's fine. But you want to make sure that you're reducing the radical as far as you can. So after having seen this, you should be able to complete the MathXL reducing radicals assignment, parts 1 and 2. You should be able to do numbers 10 through 18.